I thought this was a really unusual question when I first saw it, but you do get these ones where you sometimes have to think outside the box a little bit. The first bit's not too bad. So let's just say Z is equal to R cis theta. So we're going to reflect it in the real axis, which means we want the conjugate. So that's going to be R cis negative theta. And then we're going to rotate negative pi by 3 about the origin. So we know that in that case, we just add the arguments. So let's just call it Z2. And it will be R cis negative theta take pi by 3. So that's that bit done. Now f of w is equal to negative I w bar plus 2 plus 2i. We've got to do that for each one of these. So f of 2 plus 2i, now you can use your class pad for this, but I'm not going to, is negative I. The conjugate is 2 minus 2i. Then I'm going to go plus 2 plus 2i. So that's negative 2i plus 2i squared. So that would end up being minus 2 plus 2 plus 2i. And that appears to be at the origin. So let's do the same thing for this one here. F of 1 minus 2i is going to be negative I 1 plus 2i plus 2 plus 2i. So that's negative I, take away 2i squared, that will end up being plus 2 plus 2 plus 2i, and that is 4 plus I. So we've got negative 3 plus I. So f of negative 3 plus I is negative I, negative 3 plus I, plus 2 plus 2i. So that's going to be 3i minus I squared. So that's going to end up being plus 1, plus 2 plus 2i. So that's 3 plus 5i. Sketch each point W and join it with a dotted line to its image. So this one's at 2, 2. The image was at the origin. Join it with a dotted line. So 1, negative 2, which is there, and 4, 1, 2, 3, 4, 1 is there. Then we had negative 3, 1, 1, 2, 3, there. And that one joins to 3 plus 5i, 1, 2, 3, 4, up there. Now that's suggestive of some sort of reflection. It seems to me the mirror line would be like that. So in the last part, when we're asked a geometric transformation, it's starting to make me think whether I've got one of those correct actually, because that one's not quite going through the midpoint, is it? Let's just check that one. That was this last one. Negative 3, 1. I think we need to check that one. So that's 3i minus I squared, which is plus 1, plus 2, plus 2i. That is 3 plus 5i, but I've not put that in the right place. So it's a good job I checked. 1, 2, 3, 2, 3, 4, 5. It's right up there. Still doesn't look quite right. I'll check it again in a minute. I think it's a reflection of this line here. And if we think about that line, it's got an intercept at 2, and the gradient is -1. So in Cartesians, it's minus x plus 2. So that's imaginary z is equal to 2 take away real z. There's a reflection. Okay, I know that one didn't look right, so I'm just going to make my adjustment to that. So this, of course, was the conjugate. So it should have been -3 take away I. That's right, and then that would have given me -1 here. And so that would have been 1 plus 5i. Now I could see from the other 2 points it was going to be a reflection, but I knew I'd made a mistake. So yeah, that looks much better. Okay, happy with that now. And this is the thing, you know, sometimes if you do make a mistake and 2 things seem to fit with something and the other thing doesn't, then it's worth going back and just checking.